So this presentation is headed The Full Circle of a Statistics, and here's statistics in Greek, project. Because a research project starts with a research topic, okay? And from that topic can arise a research question. It is the original originator of the research. It is the question that should be answered by first collecting data after a hypothesis has been suggested. The research project sets out to answer the research question. So therefore now, a hypothesis now is a presumption or suggested explanation. It is a statement or sentence, if you will, made on the basis of limited evidence as a starting point for further investigation. In other words, it's a possible answer to the research question with little or no empirical evidence from collected data. So you collect the data after you have the research question, you have the research topic. A question comes up for the research question. I say, what is the average height of, of Dominicans? Then you have a hypothesis, which is a possible answer. The average height of Dominicans is 5 feet 9 inches. Okay. Then to verify the truthfulness of the hypothesis, you go to collect data, you collect the heights, and that will be a sample. You organize the data, represent the data, analyze, do your calculations, and to make informed decisions. Okay. So that will be the full circle, if you will. You're coming back to the hypothesis that has been stated. Again, it says the full circle of a statistics project, the research topic. Okay, so here now it has a little bit elaboration going on. The research question is the originator of the research. Okay, the research project sets out to answer the research question. This question is posed to the population. Therefore, it is referred to a variable called a parameter. So anytime you're talking about a variable for population, you're talking about a parameter. Now the hypothesis now is a supposed answer, a possible answer, all right, to the research question. Okay, it provides a tentative value to the population parameter. What is the average height of, the topic is the height of Dominicans. Research question, what's the average height of Dominicans? Hypothesis, the average height of Dominicans is 5 feet 9 inches. Okay, that's the hypothesis. I'm talking about the population parameter to verify whether or not you collect data, and that will be using survey tools to obtain a sample. You organize the sample in frequency tables using statistical software, represent the sample in the form of diagrams, and then you analyze the sample by calculating descriptive measures to describe the data set called sample statistics. So anytime you say you do calculations from a sample, it is called sample statistics. So then here now we're going to conclude after testing the hypothesis, which is the claimed value of the population parameter using sample statistics. Okay, so bear that in mind. Now hypothesis testing. Okay, remember where the hypothesis came from, a possible answer to the research question. That hypothesis has to be tested because it was made using little or no data. Okay, hypothesis testing is the theory, methods, and practice of testing a hypothesis. The hypothesis, as we know, is a proposed answer of the research question based on limited evidence. Hence, data has to be collected in order, all right, to test its truthfulness. Now, there are different approaches for hypothesis testing. The ones we're going to study here will be the critical value or classical approach. You have what you call the p-value approach, and you have the p-value approach using Excel or other software like SPSS, Minitab, R, and so forth. The hypothesis test that we are going to study in this course, you have the z-test for mean, okay, and the chi-square test, goodness of fit, with 3 versions we're going to study: the chi-square for variation, chi-square for randomness, and chi-square for independence. So these are the 4 hypothesis tests we are going to study for this course. Okay, there are more, but these are the 4 that is reserved for this course. Okay, z-test for mean, test for variation, chi-square test for randomness, and for independence. Now, the first step for a hypothesis test using the classical approach is to state a pair of hypotheses. For the z-test for mean, this is the table that is going to be used, because for the z-test for mean, you have to convert the statement. Remember, the hypothesis is a sentence with words, you have to convert the sentences using this table there. Sentences have to be converted to symbols, sentence to symbol, sentence to symbol. That is for the z-test for mean. But for the chi-square now, the hypothesis will be in words. It have to remain in words. The hypothesis will come in pair. One is called the null, HO, and one is called the alternative. So the first step is to state a pair of hypotheses. Okay. That's the first step in performing a hypothesis test. Okay, so state a pair of hypotheses. And for the z-test for mean, the wordy sentence have to be converted to symbols. Okay, but for the chi-square test, it have to remain in words. Okay, and here are the three pairs of hypotheses for the chi-square, and these are the three possible pairs for the z-test for mean. Then the second step is to sketch what you call a distribution curve. For the z-test for mean, it will be a bell shape. For the chi-square, it will be skewed to the right. That's the second step. Remember, we're talking about the classical approach or the critical region approach. The third step is to locate and shade a critical region. So the critical region can be on the right, on the left, or the two-tail for the z-test for mean. The dependence on the direction of the critical region will depend on the HA for the z-test for mean. So if the HA symbol is pointing to the right, so that's why you have to convert the word to symbolic form so you can get the symbols for you to know what tail for the z-test. So if it's pointing to the right, that's a symbol for the HA, then it's a right tail. If the symbol for the HA is pointing to the left, it's a left tail. If the symbol for the HA is not equal, it's a two tail. That's for the z-test. But for the chi-square, it's a bit simpler. It's always a right tail. So that's the third step is the critical region. For the chi-square, it's always on the right. Okay. The fourth step now is to place a critical value on the critical point. Here's the critical point right where the borderline is from the unshaded to the shaded. Okay. And we have to put a critical value on that point. Okay. The fifth step is to calculate what you call a test statistic. Here are the formulas for the z-test and the chi-square test to calculate the test statistic. Okay. Although we have three versions for the chi-square, the formula for the test statistic is the same. All right. Then the sixth step now is to, all right, we're going on to the sixth step, is to plot the test statistic on the distribution curve. So you must look at the value of the critical value in order to plot the test statistic on the correct position on the number line. So all in all, this curve have to have two values, one for the critical value on the critical point, and another value is the test statistic. So it can come in the critical region, it can come in the, meaning the test statistic in the unshaded region, depending on the value, depending on the respective values. So that curve, all in all, in step number 6, by the end of step number 6, must have two numbers on it, two important numbers, the critical value and the test statistic. Okay, so depending on where the test statistics is, then you can make a decision. Remember, we started with two statements. One is the null and one is the alternative. That's how we started at step number 1, a pair. Okay, one is called the null and one is called the alternative. So when it comes to step number 7, if the test is located in the rejection region, then you reject the null. If the test statistic is not in the rejection region or is in the unshaded region, you do not reject the null. Okay, and the last step for critical value approach is the conclusion. Remember, you started with two statements, two hypotheses, and one of them will be the conclusion, either HO or HA, depending on the decision in step number 7. Okay, so therefore now, if the null was rejected in step number 7, okay, then the alternative is the conclusion. If the null was not rejected, then the alternative, then the null itself is the conclusion. Always remember that you will start the test with two statements, the null and the alternative. After the test is done, only one will be the conclusion. Okay, so for example, if you say, well, the average height is 5 feet 9 inches, and you do your calculations, and then you do your decision making in step number 7, then you can either reject that statement or not. So that is the critical value approach. Then you have what you call the p-value approach, which is a little bit simpler. But the first step is the same. You have to start with a pair of hypotheses. But you also have to establish what you call a significance level called alpha. That's the symbol for it. You can either choose 0.01, 0.025, or 0.05 is popular. It is very common to choose 0.05. It is allegedly defined as a probability of making a type 1 error. So therefore now, in the p-value approach, you have to, apart from stating a pair of hypotheses, you have to establish a significance level. That's a must, a probability value. So you can just choose 0.05. Okay, the statisticians are okay with that. Then you can have to, step number 2, you have to calculate the test statistics. We came across that step already. Here are the formulas. So you have your pair of hypotheses, you have your significance level, then you calculate the test statistic. And in step number 3, you're going to use that statistic now to calculate or to obtain a p-value, another probability value. So in the critical value approach, you are comparing the critical value and the test statistic on the curve. Okay, that is the critical value approach. You have a critical value and a test statistic on a curve to allow you to make a decision. But with the p-value approach, it's 2 probability values you're going to compare. One is called the significance level. It's almost playing the role like the critical value. And the other one is called a p-value, which depends on your calculations. And you're going to compare those 2 probability values. Okay, because the alpha value is a probability value. So you compare the p-value to the significance level. All right. Decision. You reject the null if the p-value is less than the significance level. And you do not reject the null if the p-value is greater than a significance level. And conclusion, if the null is rejected, then the alternative is the conclusion. If the null is not rejected, then the null itself is the conclusion. Okay, now you have the p-value approach now using Excel. Okay, the p-value approach using Excel, SPSS, Minitab, R, or any other statistical software. Again, you state a pair of hypotheses. But what you do now, you input, you don't calculate the test statistics like how we did for the p-value approach and the, critical value approach. You put all those values, the data, your data in Excel or SPSS or Minitab or R or any other statistical software. This software will do the calculations for you and give you an output. So in that output, you identify the p-value, okay? And then you compare that p-value to your significance level. And again, you reject the null if the p-value is less than the significance level, or you do not reject the null if the p-value is greater than the significance level. And step number 7, your conclusion time. If the null is rejected, the alternative is the conclusion. And if the null is not rejected, then itself is the conclusion. So here you have the 3 approaches. Okay, so we'll start with the critical value approach. Okay, you have the z-test for mean and the chi-square test for variation, for randomness, and for independence. Okay, and very importantly, for the z-test for mean, you must convert the worded sentence of the hypothesis to symbolic form. That has to be done. With the chi-square, this is not the case. The hypotheses remain in worded form. Okay,